Hi, welcome to my video on find the value of theta as a radian in terms of pi. Find theta as a radian in terms of pi. Recall, 180 degrees is the same as pi radians. 180 is halfway around a circle of 360, and 2 pi on a unit circle is the total circumference, so pi is halfway, pi radians. To change a radian to a degree, we multiply by 180 over pi. So we multiply by 180 degrees over pi. The pi's cancel, and 2 divided into 180 is 90. So pi over 2 is 90. 5 pi over 6, we multiply by 180 over pi. Notice the pi is on the bottom to cancel out. 6 into 180 goes 30. 5 times 30 is 150. We multiply by 180 over pi. The pi's cancel. 4 divides into 180 45 times. Negative 3 times 45 is a negative 135 degrees. And a negative pi over 3, we multiply by 180 degrees over pi. Pi cancels. 3 and 180 goes 60, so we have a negative 60 degrees. So the reverse is true. To change a degree to a radian, we multiply by pi over 180. So notice pi over 180. Notice there's no pi in this, so to keep the pi on the top, we do cancellations. 0 cancels. 3 into 33 goes 11. 3 into 16 goes 6. So we get 11 pi over 6. And negative 120 degrees, we multiply by pi over 180 degrees. Notice the zeros cancel. And 3 into 12 goes 4. 3 into 18 goes 6. So 2 into 4 goes 2. 2 into 6 goes 3. So we get a negative 2 pi over 3. 270 multiplied by pi over 180. And again, the zeros cancel because we're dividing by 10. 9 into 18 goes 2. 9 into 27 goes 3. So we get a 3 pi over 2. 270 is 3 pi over 2 radians. And we get multiplied by pi over 180, and we see a 5, so 5 divided into 180. 5 into 18 goes 3, so that's 36. And 5 divided into 225 is a 45. And I see a 9. 9 into 36 goes 4. 9 to 45 goes 5, so we get a negative 5 pi over 4. So that's converting radians to degrees, multiplied by 180 over pi. Change degree to radian to multiply by pi over 180. Now let's move on. To solve in terms of a radian, I'm going to solve in degrees and convert degrees to radians in terms of pi. So I'm going to do the same as I did before in the previous videos. Then when I get degrees, I'm going to convert them to radians. That's the best way I found to do it when I was learning the math. Sine is negative 1. We got to solve for theta. Notice from 0 less than equal to theta less than 2 pi. Notice this is in terms of pi. So that means I want the answer in terms of pi, in terms of a radian. So sine is 1. Draw a circle. Sine is related to the y, so this right here is 1 comma 0. This is 0 comma 1. This is negative 1 0. This point is 0 negative 1. So sine is 1 at 90 degrees. So theta is equal to 90 degrees. So 90 degrees multiplied by pi over 180, and 90, and the 90 goes once, 180 goes 2, so theta is pi over 2 as a radian, because we want radians. If I had degrees here, then this would have been the answer, but I want radians, pi over 2. I want it in terms of pi. B, another example. Cos theta is a negative root 2 over 2, and 0 less than or equal to theta less than 2 pi. Again, this indicates I want it in radians. So we have to look at where sine is negative. So we add sugar to coffee, or we do the cash rule and start with C here. So cos is negative, cos is positive in 1 and 4, so it's negative in 2 and 3. So we'll draw the diagram in 2 and 3. We draw two separate ones so you can see the rotations. And so we're drawing the terminal arm in 2, and we're drawing the terminal arm in 3. And as a result, the perpendicular goes to the x-axis each time, always to the x. Cos is associated, or is the x on the unit circle. This is the unit circle, because that's this point is 1, 0, indicating the radius is 1. And we have x is a negative root 2 over 2. X is negative root 2 over 2 in both quadrants. And that means since that's root 2 over 2 automatically, the other side is root 2 over 2, positive. And this is the negative root 2 over 2. But because I have root 2 over 2, I know the reference angle is 45. Reference angle is 45. So in the second quadrant, theta is 180 minus the reference angle. So that's 180 minus 45. So that's 135 degrees. And 135 degrees, we want it as a rate multiplied by pi over 180. Again, 5 into 180 goes 35. Yes, 35 is 36, sorry. 5 into, it goes 25, and we divide by 5 is 2, and there's 3 left over, so that's a 7. I can't divide now. And 9 goes into 27 3 times, 9 goes into 36 4 times, so theta is 3 pi over 4. Interesting to note that the reference angle, I put the reference angle in, I didn't write it down, but I put it in. The reference angle is 45. Notice the 45 is a pi over 4. Notice the pi over 4 here. So that's 3 45s, which is 135. So this is a 45. Pi over 4 is a 45. So therefore, the answer we get is going to be a multiple. Excuse me. Going to be a multiple of pi over 4. And in this quadrant, we have that theta is 180 plus the reference angle. So it's 180 plus 45. So it's 225. And we convert 225 pi over 180. And 180 divided by 5 is 36. 2 divided by 5 is 45. And 9 into 36 goes 4. 9 into 45 goes 5. So we got, in terms of radian, we got 5 pi over 4. Again, pi over 4 is 45. 5 45s is 225. So these are the two answers in terms of a radian. 3 pi over 4 and 5 pi over 4. Sine is negative a half. And again, we have a radian. So where are we located? Add sugar to coffee. Sine is negative. Sine is positive in 1 and 2. Negative in 3 and 4. So let's draw the diagram separately, again, just to be consistent. There we go. And we're in quadrant 3, and we're in quadrant 4, perpendicular to the x-axis. Sine is in terms of the y, so the y is a negative a half, and the y is a negative a half, and the x is root 3 over 2, hypotenuse 1, and this is the negative root 3 over 2, so a half, opposite a half is 30, and this is a 60, opposite a half is a 30, so in the third quadrant, theta is 180 plus the reference angle, so it's 180 plus 30, which is 210, and 210 degrees multiplied by pi over 180, zeros cancel, divided by 10, 3 into 18 goes 6, 3 into 21 goes 7, so theta is 7 pi over 6. Again, the reference angle is 30, and 30 is pi divided by 6. Pi is 180. 180 divided by 6 is 30. That means this answer down here is going to be, pi, the reference angle is 30. That means this will have pi over 6. Pi over 6 is a 30. 7 30s makes 210. And in this quadrant, again, theta is, just to remind you, theta is this rotation all the way around to here. So it's 210 degrees or 7 pi over 6. And here theta is all the way around to the fourth quadrant, right to here. So theta is, excuse me, 360 minus the reference of 30, 330, and when we reduce that down to a radian, or I should say change it to a radian, multiplied by pi over 180, the zeros cancel, 3 into 18 goes 6, 3 into 31 goes 11, so theta here is 11 pi over 6. Again, pi over 6 is 180 divided by 6 is 30, 11 30s is 330. Okay, let's continue. Remember, excuse me, you can pause your video at any time and work these out. And we have some practice. Now let's solve 0 less than theta less than 0 less than or equal to theta less than 2 pi, and add sugar to coffee. Sine is the y, and sine is positive in 1 and 2, is negative in 3 and 4. Again, draw a couple of diagonal circles on it, and we're in, oop, this is positive, so I have to pick out these two. Yeah. Don't know what I was thinking then. Sine is positive. I almost made a mistake. I was going where it was negative. Sine is positive in 1 and 2. Drop a perpendicular to the x-axis. Sine is the y, so the y is root 3 over 2, and x is a half, hypotenuse 1. Sine is root 3 over 2, x is a half, but is negative in that quadrant. And opposite root 3 over 2 is a 60 reference. Opposite root 3 over 2 is a 60 reference. So the reference angle is 60. And 60 is pi divided by 3. 180 divided by 3 is a 60. So, what's the answer? Theta is the reference angle, which is 60. And 60 times pi over 180. 60 once, 3 times. So theta is pi over 3. And in this quadrant, again, theta is just in the first quadrant. theta is the reference angle, which is 60, which is pi over 3. And in the second quadrant, we rotate. There's theta. So we have theta here is 180 minus the reference angle, 180 minus the 60. So that's 120 degrees. And 120 degrees is 120 times pi over 180 degrees. Zeros cancel. 6 is 2. 6 divided is 3. So theta is 2 pi over 3. And 2 pi over 3. Pi over 3 is a 60. 2 times 60 is 120. So there's the two answers in terms of radian. Number 2. Cos is equal to a half. And where are we? Add sugar to coffee. Cos is positive. Cos is positive here and here. So we are in quadrants. Draw a circle. First quadrant, perpendicular. And we're in the fourth quadrant, perpendicular. Cos is the x, so the x is a half. And the x is a half. That means the y is root 3 over 2. Hypotenuse is 1. Opposite root 3 over 2, so that's a 60. And this is a half. This is root 3 over 2, but it's negative because it's going down. And again, the reference angle here is 60. So theta in the first quadrant is the reference angle, which is 60 degrees. And we have the same answer. Theta is pi over 3. And in this quadrant, again, theta is the rotation to here, which is 60 degrees or pi over 3. And theta is all the way around to here. So theta is 360 minus the reference angle. So it's 360 minus 60. So it's 300 degrees. It's a degree. So 300 degrees multiplied by pi over 180. And the zeros cancel. 3 into 18 goes, or divide by 6. 3 and 5. So that's a theta as a radian is 5 pi over 3. Pi over 3 is a 60. 180 divided by 3 is 60. Pi over 3 is a 60, so this is 5 60s, which is 300. So there's the two answers. Again, remember, denominator is 3, so the reference angle is always pi divided by whatever denominator is. So pi over 3 is a 60 reference, 5 times that. Sine is equal to, cos is equal to 0. So we have the circle. Cos is the x. So we have the circle. So we have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Cos is the x, so x is 0 at the 90, and x is 0 at the 270. And 90 is 90 times pi over 180. Zeros cancel. 9 and 9 goes once, 2. So 90 is pi over 2. And there's 3 90s there, so there's 3 times pi over 2. So theta in degrees is 90, 270. Theta in radians is pi over 2 or 3 pi over 2. Just want to make sure. 290 times pi over 180. Zeros cancel because you're dividing by 10. 9 to 18 goes 2. 9 to 27 goes 3. 3 pi over 2. Again, 90 is 180 divided by 2. 270 is 3 90s. There's a 90. Pi over 2 is 90. 3 times that. That's how come I know. You see it so often, and when you see it so often, you'll learn. And that brings us to converting theta to radians when you solve an equation. Again, note, this is the domain. This tells you where you're picking your answers from. If it's in degrees or in radians. So We'll do that again in the next video. That brings us to the end of the video. If you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video.